Let's work through an old exam question in which stoichiometry is applied in an equilibrium situation. And this old exam question comes from the Mpumalanga September 2017 exam. We're going to look at question 6. So you should pause the movie and try to answer these questions before you continue. Let's start with question 6.1. Question 6.1 has to do with Le Chatelier's principle. It says that we have the Haber process in which nitrogen and hydrogen react together to form ammonia. And then what happens is we decrease the temperature. There's a drop in temperature. And we want to know what does that do to the rate of the forward reaction, the yield of ammonia, and we must explain those two answers referring to Le Chatelier's principle. In order to do this, we need to understand what this here means. This is the change in enthalpy, meaning the change in the energy stored within the chemicals during the reaction. And this change is smaller than 0, which is another way of saying that it's negative. Less than 0 is negative. So what this means is that this reaction is exothermic. How can we see that? Because this is saying that the change in enthalpy from the reactants to the products is negative. So the products have less enthalpy than what the reactants had. For the products to have less enthalpy than the reactants, more energy must have been released during the reaction than what was absorbed. In other words, the reaction is exothermic. Now this question is asking about what happens when we drop the temperature. What does that do to the rate of the forward reaction and the yield of the ammonia? So we are going to make the situation cooler. That is the disturbance we are going to cause to the equilibrium situation. And the system will react to try to undo what we've done. We've tried to cool the system down. It will try to warm the system up. Which reaction, forward or reverse, warms the system up? Well, we've just said that the forward reaction is exothermic. So it is going to be favored during this disturbed period. And in so doing, the system is going to be warmed up, undoing the cooling effect that we caused. Eventually, a new equilibrium will be reached, where both forward and reverse reactions are at the same rate as one another, but since temperature also changes the Kc value, at the new equilibrium, the reaction is going to lie more to the right than what it did before, so the yield of ammonia is going to be greater. So cooling the system down shifts the equilibrium to the right, increases the rate of a forward reaction, increases the yield of ammonia. And that can all be explained in terms of Le Chatelier's principle because cooling the system down favors the exothermic reaction, which is the forward reaction, as the system tries to counteract the cooling disturbance imposed on it. In the next movie, we'll look at the rest of this question. We'll look at 6.2 where we do this calculation. See if you can't first answer it yourself.